Okay, ladies and gentlemen, this is the last lesson that introduces new content in the trigonometry unit. So you've come a long way in your understanding of these trig functions already. What we're doing here is what we've been building towards for the entire unit, which is being able to evaluate functions with our trig ratios inside of them. So f of x is equal to cosine of 2x. So to some extent, we're back on familiar territory, right? So we have a function. We're no longer just like dealing with these trig ratios sort of all on their own, right? So this works exactly how you would expect. So the nice looking notation would be f of 5 pi over 12 is equal to cosine, I'm going to say parentheses, of 2 times 5 pi over 12. Okay, so the key here is order of operations. So I'll talk about what that means here in a second. We'll finish this one first though, because this is an easier one. 2 times 5 pi, the easiest way to tackle this is by just multiplying. 2 is 2 over 1, so just multiplying the fractions together. You get 10 pi over 12, and then I actually have to reduce, so there's no 10 pi over 12 on my unit circle. I'm going to divide the top and bottom by 2, and I get 5 pi over 6. Okay, so I want cosine of 5 pi over 6, and then I look it up in the unit circle. Remember, cosine is x. This gives me negative root 3 over 2. Okay, and again, what this graph looks like, the reason this is useful, is this gives us kind of this cool wavy graph. So it allows us to analyze things that follow kind of cyclical patterns. So in the next lesson, you'll look at some word problems where these types of functions model some real life stuff. I'm excited that we finally have made it to this point where we can start applying this to real life a little bit in like a rigorous, like pre-calculus way. So this is my solution here, and then I can make a whole math statement. I could say f of 5 pi over 12 equals negative root 3 over 2. Okay, let's look at a couple more, and I'll clarify what I mean by order of operations. So here's a great one to contrast with the previous one. So f of x is now 2 cotangent of x. If you say cot x, by the way, it hurts my soul, so please say cotangent. 2 cotangent of x, and we want f of 5 pi over 6. Okay, so f of 5 pi over, pi over 6, I'm thinking of the last one. F of pi over 6 equals 2 cotangent pi over 6. And notice the 2, there's a 2 in both of these problems, but the 2 shows up in a different place. Okay, so this is what I mean by order of operations. In this problem, we're going to find cotangent of my angle first, and then multiply it by 2. In the previous problem, we're going to find, we multiplied by 2 first, and then found the cosine of the result. Okay, so I guess what I mean by order of operations is this. So pay attention to whether your operations are inside or outside the trig ratio, because that tells you what order to do things in. So this is the 2 times x is inside the trig ratio, so we multiplied first. Here it's outside, so we're going to find cotangent first and then multiply by 2. I could rewrite this if I wanted to, right, as cosine pi over 6 over sine pi over 6. Because tangent is sine over cosine and cotangent is the reciprocal of that. Okay, so I'll look that up in my unit circle. That's root 3 over 2 is cosine and sine is 1/2. So this becomes root 3 over 2 over 1/2 times 2. Okay, this is pretty ugly looking, but notice 2 and 1/2 are opposites. Well, actually, we can't do that because dividing by 1/2 flips the fraction. So we're going to take the reciprocal of 1/2, so we get 2 times 2, and then we get root 3 over 2. Okay, so 1/2 dividing becomes 2 over 1. I do have at least one set of 2's that can cancel out, though, and I get 2 square root 3. Okay, by the way, your calculator can do these if you switch to radians mode, so hit that mode button and change it to radians. However, it won't give you the exact answer. So that's the benefit of being able to do these by hand, is 2 root 3 is exact. Your calculator will only give you a big long decimal that you have to round. And sometimes when we do applications of these, we need an exact answer because it's more precise. Make sure, pause for a second, make sure you understand how I solved this one, including this cosine over sine, why did I do that, and including how I simplified this fraction here. Okay, so I took the reciprocal of 1/2 because I'm dividing by it, got 2, canceled out 2 divided by 2, and this was left over. Now would be a great time to just pause, rewind if you need to, reflect, and then we're going to move on to one additional point here. Here, we got something weird, right? So we got tangent and then exponent of 2x. The reason this was weird is tangent isn't a number, right? Tangent is a math operation. This is like, at first glance, looks like we're doing like plus sine squared, which you guys know is just like absurd, doesn't make any sense, right? You can rewrite this as f of x equals tangent of x, in big parentheses like that, squared. That's what that means. The reason that we write it this way, tangent squared of x, is because if you write it this way and you don't use parentheses, it looks like tangent of x squared, right? And we want to avoid confusion, so we put the tangent, or we put the squared on the tangent, just so it's super clear what we're squaring, and it's the whole thing that we're squaring, because this looks like this, right? But you can rewrite that if you want like this, just make sure you use parentheses around the whole thing. And then it's just like we did before, so I shouldn't say equals there, I should say f of 11 pi over 6 equals, right, tangent of 11 pi over 6 squared. Oh, I almost did the exact thing I was talking about. We're squaring the whole thing. I'm going to look up sine and cosine to get tangent in the unit circle, right, of 11 pi over 6. It's my very last one. That is 330 degrees. And sine over cosine, so I'm going to do negative 1/2 over root 3 over 2. And all squared still. Okay, and then this one, we're going to have to simplify it. Again, it's looking kind of ugly. Remember, that's sine over cosine this time because we did tangent. So the first thing I'm going to do is I'm going to divide the fractions, which means I multiply by the reciprocal of the bottom one. So I get negative 1/2 times 2 over root 3, all squared still. My 2's cancel, which is kind of cool. And then I get negative 1 over root 3 squared. And then to square this, it's negative 1 over root 3 times itself, right? So negative 1 times negative 1 becomes a positive 1. Root 3 times root 3 becomes just plain old 3, which is a nice, simple, exact answer, which should bring you a little bit of joy, I think. So watch out for this notation, this squared on tangent, and just know that it means square the whole thing. So that comes after the trig ratio in the order of operations. Okay. Make sure you have a good couple of examples captured here. Make sure you have your unit circle, and you'll have an okay time with these. If you don't have those two things, you'll probably have a hard time with these.